Hello, my name is Michael Fisher. I'm a Principal Specialist Solutions Architect focusing on EC2 Graviton, and I'm here with my colleague Vishal Manan as well. Today, I'm here to talk to you about AWS Graviton and how you can adopt AWS Graviton for all of your compute workloads. And the fact of the matter is, you're probably already ready to adopt it. And today, I'm going to talk a little bit about what makes Graviton so special, and some of the ways in which you can quickly adopt Graviton from managed services to managed compute to using EC2 instances and containers as well. And we'll also be talking about a new tool that we've developed that will help you adopt Graviton rapidly as well. So I'm just going to start with a very quick overview of AWS Graviton processors. AWS Graviton processors are exclusive to Amazon Web Services. They are built on custom silicon that has been invented and produced by us, and they use 64-bit ARM processor cores. These ARM processor cores may be very familiar to you. If you're using a mobile device today, like an iPhone or Android phone or a tablet, or even if you're using one of the new Apple Macs with Apple Silicon, these are using ARM64 processor cores already. And we'll talk a little bit about the advantage of these as well. We've built these new Graviton processors based on our experience working with customers on all sorts of compute workloads. These workloads count are for everything from web services to very, very large financial and industrial applications to machine learning and AI. And what we've been able to do by inventing our own processors is to rapidly innovate and iterate on customers' behalf. And we're already on our third generation of Graviton processors. These are known as Graviton-3, and you can find them in our C7G, R7G, and M7G processors, with many more to come. We recently also announced C7GN, which are our most advanced Graviton 3E-based processors that have up to 200 gigabits networking available. So why should you as a customer choose AWS Graviton? Well, compared to instances that are based on the x86 CPU architecture, there are three distinct advantages that AWS Graviton provides. Number one is that AWS Graviton offers up to 40% better price performance for scale-out workloads. This basic, and the way that we achieve this 40% better price performance is through two different ways. One is each instance costs up to 20% less per instance hour than x86 compute. So this basically means that for every Graviton instance that you use, you're paying up to 20% less for the same number of vCPUs, the same amount of memory, the same instance storage, the same networking. So that's savings that you can begin to bank on right away. And the other up to 20% price performance comes from the fact that with Graviton, each vCPU or virtualized CPU is actually a full CPU core with all of the power available in that core. Unlike x86, Graviton does not use hyperthreading. And so every core is a real core. And because of that, you're able to use EC2 instances much more efficiently and have them do much more work per instance than you could before. On top of that, Graviton uses up to 60% less energy, or up to 60% more energy efficient than x86. And this is because of Graviton's advanced technology and its unique CPU architecture. So you're able to run the same workloads and use 60% less energy, which accounts towards overall sustainability, which we know is very important to many of our customers. So let's talk about how you can take advantage of Graviton starting today. There are many different ways to use Graviton. Number one is through AWS managed services, and I'll talk a little bit about that on the next slide. Number two is by taking advantage of AWS Lambda functions. With Lambda functions, you can often take your existing code and run it on ARM64 or Graviton without doing any changes at all. Next, I'll talk a little bit about managed compute for containers, specifically AWS Fargate. And then we'll talk a little bit about how you can run your workloads and migrate to Graviton using Amazon EC2 instances. AWS managed services are already available for Graviton today. So whether you're using Amazon Document DB, Amazon Aurora, Amazon RDS, Amazon Elasticache, Amazon Memory DB, Amazon NetTune, or Amazon OpenSearch, you can actually begin using Graviton with those today. As a matter of fact, if you create a new cluster or instance with any of these services, the default instance family will be Graviton simply by when you go to the console and create a new instance or a new cluster. So, and on top of that, all of these managed services provide a migration path for you to go from x86 to Graviton easily and without incurring any downtime. Of course, we recommend that before beginning the migration, you should always take a backup. And you should perform that process at a time that's most convenient for you. And ideally, when demand is low, in order to make the process as seamless as possible. Next, I want to talk a little bit about AWS Lambda. For most customers, migrating to Graviton for your AWS Lambda functions is very smooth sailing, no choppy waters at all. That's because in our research, we found that most customer Lambda functions are simply scripts written in Python, PHP, Node.js, Ruby, and so on, without any native code that is architecture specific. And these scripts or Java jars if you're using Java are simply placed in a zip file and uploaded directly to Lambda or placed in S3 where Lambda can easily reach them. So in order to migrate your Lambda function from x86 to Graviton, all you need to do is create a new Lambda function with the exact same configuration as your existing Lambda function and simply change the architecture of that Lambda function definition to ARM64. You can often reuse this exact same zip file with no changes at all, switch the architecture, and begin saving up to 20% immediately for your Lambda functions without any loss in fidelity, behavior, any changes in behavior, or performance changes. Now, if you're running your own application outside of Lambda, your ease of adoption will vary depending on the type of application you have and what software your application is written in. For most customers, it turns out that adopting Graviton is quite easy. And that's because many of our customers are using interpreted and languages that are built that use a bytecode compiler, such as Java or .NET. If that's you, and we suspect many of you are, then migrating to Graviton is actually quite easy. So if your application is written in a scripting language, such as Python, PHP, Ruby, or JavaScript, or if your application is written in Java, then migrating to AWS Graviton is going to be fairly straightforward. And I'll talk a little bit about the ways in which you can accomplish that shortly. If, on the other hand, your application is written in a compiled language, such as C, C++, Go, Rust, or the like, then your application may need to be compiled specifically for ARM64, which is the architecture Graviton uses. And so this may require cross-compilation before building your application, or it may require you to recompile using a native compilation environment. So you would start, for example, a Graviton instance and compile your application there. But what we found is that for the vast majority of software that does require compilation, especially if it's open source software, it's already available and it has been tested on ARM64 already. So the difficulty, it may not be as difficult as you fear that it could be. For those of you running .NET applications, it's important to understand that Graviton currently only supports Linux as the operating system. And so you would need to make sure that your .NET application runs on .NET Core, .NET 6, or .NET 7. And if that's available to you, then it's very similar to running a Java application. That is, you take your .NET assembly after it's been compiled, and then you can run it on Graviton without any difference in behavior as well. For those of you who do require Microsoft Windows to run your workloads, unfortunately, Microsoft Windows Server is not yet available for ARM64. If and when that changes, we'll have more to say, and we'll present new videos for you on how you could be able to use Microsoft Windows on Graviton in the future. So the easiest way to use Graviton is through managed compute. Just like with AWS Lambda, we have the ability to run containers on managed compute on AWS as well. And that's through AWS Fargate for Amazon ECS. As I said, Fargate is all around running containers using managed compute on Amazon ECS. And the great thing about containers is it provides a unified control plane for managing your application lifecycle. This includes starting containers, managing groups of containers through a service abstraction, registering your containers with a load balancer, integrating with service discovery, integrating with service mesh, and much more. So in order to use Graviton very easily with your containers, all you have to do is create an ECS cluster and create a task definition that declares the essential aspects of your task. For example, the image, the ports that it's listening on, how much CPU and memory the application needs, any volumes, environment variables, and so forth. And in that task definition, to run on Graviton, all you need to do is specify a CPU architecture of ARM64 in the task definition's runtime platform attribute. This runtime platform attribute defaults to x86, but you can simply declare ARM64 instead. And when you do that, your containerized application will run on Fargate for Graviton instead. It does require that your container image be built for ARM64 or be a multi-architecture image. That is an image that's capable of running either on x86 or on ARM64. And we have a tech talk that describes how to build that in depth at the YouTube link provided here. So take a look at that YouTube video. It was presented by me. And if you have any questions about it, feel free to write me. My email address will be shown at the end of this presentation. So it's important to know that if you're building a containerized application for Graviton, the good news is that almost all major container base images, including Docker official images, are already compatible with Graviton. This includes most major operating system distribution base images, such as Ubuntu, Debian, Alpine Linux, and of course, Amazon Linux 2 and Amazon Linux 2023 as well. These are already available for ARM64, and so if you are building your containers either natively or emulated for ARM64, you'll find that those are already available. Not only OS distribution images, but also language-based base images are available for ARM64 as well. This includes Java, Python, Node.js, Ruby, and many more. So, and also we and Docker Hub have made it very easy for you to locate and determine whether or not those base images are available and usable on Graviton. If you go, for example, to the Amazon ECR public gallery at gallery.ecr.aws, you can simply tick the architecture box on the left-hand side, fill in the ARM64 tick box, and it will show you all of the matching images that are available for ARM64. Similarly, for Docker Hub, you can search by architecture by clicking the ARM64 checkbox, and it will show you which images are available for ARM64 as well. I think you'll find that regardless of the base image that you're looking for, you'll probably find it for ARM64, and that will actually make your transition to Graviton much, much easier as well. Now, if you're going to be deploying your application directly on Amazon EC2, or perhaps you are using Amazon EC2 instances as part of your container node fleet. We have good news for you there as well, because all major Linux operating system distributions that have been released in the past few years already have compatible AMIs for Graviton. This includes Amazon Linux 2, Amazon Linux 2023, which just went generally available, Ubuntu 18 and later, Red Hat Enterprise Linux 8.2 and later, compatible enterprise Linux distributions such as Rocky and Alma Linux, also SUSE Enterprise Linux. All of them are available for have AMIs available for ARM64. And AMI preparation services and software, including Amazon EC2 Image Builder and Packer, already support Graviton as well. And if you want to find a compatible AMI that would be useful as a starting image for you, or if you just want to run the AMI directly, you can go to the EC2 console, as I'm showing here, click on AMIs under Images, and then select Public Images from the drop-down box. And then in the search box, you can start typing architecture, and it equals ARM64. And you can add any other search terms you want, and that will help you find the AMI that you're looking for that is just for you. Now we're going to talk about a tool we've built to help you evaluate your applications so that you can quickly and easily determine if they're Graviton capable, which they probably are. My colleague Vishal is going to introduce to you and speak about Porting Advisor for Graviton. Take it away, Vishal.
Thanks, Michael. My name is Vishal Manan, and I'm a specialist SA focused on Graviton in AWS. So I'm going to talk about a newly announced tool. It's called Porting Advisor for Graviton. And the Porting Advisor for Graviton is a tool which scans for potentially unsupported or non-portable ARM64 code in your source tree. The tool only scans source code files and dependency files. So for example, the requirements file for Python. And the tool doesn't make any code changes. This doesn't provide any API level recommendations. And more importantly, it doesn't send any data back to AWS. You can use this tool as a Python script or compile it into a binary, and you have the flexibility to run it on an x86 system or ARM64. Currently, the languages supported are C, C++, Fortran, and Golang version 1.11 onwards, Java 8 onwards, and Python 3 onwards. So this shows a high-level working of the Porting Advisor. It's a very simple to use tool, and you can see the architecture is that you could run it as a script or a binary, as I mentioned earlier. It requires Python 3.10 on the host, and you can pick a PC or an Amazon EC2 instance, which could be x86 or ARM, or it could run on a Mac. And if you have Java code, you would need to install Java 8 plus or version onwards. The input to the tool is a folder with your source code and the languages I mentioned earlier. And the tool spits out a report, which could be in CSV format or HTML format, based on the choice you have picked. So the skill set needed for using the tool is pretty basic. You need to have an understanding of the build system, so your requirements file, dependencies, versioning, etc. You need to have some knowledge of scripting, either with Python, PowerShell, or Bash Shell if you're using Linux. And understanding of hardware-specific assembly or compiler-specific intrinsics if you have C, C++ code. Otherwise, that's not needed. So what are the issues this tool can find? The tool is very highly oriented towards compiled languages like C, C++, whereas Michael had mentioned that's where you might see a little more challenge in moving to Graviton. And the tool would help you identify things like where you have an inline assembly for x86 and nothing for ARM64. So it'll point that out to you. Same for intrinsics. If you're using x86 intrinsics, it'll actually point that out to you. It will also help you find out any preprocessor errors that may show up when you compile an ARM64. The tool one of the most important things that the tool would do for any language is to find what libraries are available for ARM64. And as you can imagine, there are thousands of libraries out there. So the tool cannot identify everything. So keep that in mind, that is not an exhaustive search of all possible libraries that you would be using, but it will identify the most generally available libraries. Furthermore, if you're using old Visual C++ runtime on Windows, the tool will actually flag that. Now, the tool will not report anytime you're using compiler-specific code guarded by compiler-specific predefined macros. That's not reported. And anything that is specific to the host, not the target. So we talked about the host here, where you're going to be running the tool. The target in this case is Graviton. So if you are using anything like an x86 host and a build process uses a script which actually detects the kind of host, that will not be as you want that to be the case. Finally, as I mentioned, it's not exhaustive in finding all possible issues. So I'm going to do a quick demo of the tool. And there are two links here, which I wanted to actually highlight. The first one is a blog I had written earlier about the tool. And I want to highlight a few things about the blog. The blog actually calls out a few different things. In case you're using an EC2 instance, let's say L2, Amazon Linux 2, that is, and it doesn't come up with 3.10 version of Python installed. If you're running into issues either with compiling Python, you could actually go and look at this section of the blog. So if you run into any issues regarding either building Python 3.10 on Amazon Linux 2, the blog actually has some resources mentioned here. There is a website which actually talks about how would you go about installing Python 3.10 on Amazon Linux 2. And besides that, this is what you may also run into with the PyInstaller. Now, PyInstaller builds a binary for using the Graviton porting advisor. It is not using it as a script. And if you decide to go that way and you don't have to, then you might be running into issues with the shared library. And if you run into those issues, this blog comes in handy. So getting back on the demo, now this is the GitHub site, and you'll have a link to that, which has all the scripts and all the source code needed to build the tool. And so I'm going to demo a few different things today. So the first thing I want to talk about is how to build this tool. And let's say you want to build it on Windows. In that case, there is the build script. It's a PowerShell script, and it is pretty straightforward. The first thing the script does is it actually sets up the Python environment. And after it sets up the Python environment, it downloads all the packages needed right there. And after that, it uses PyInstaller to build the binary. So let's quickly kick it off and see. I want to just show you how that would work. Okay, so I'm just going to, this is for your safety so that scripts are not available by default. That's going to take some time, and you'll find that the output goes into a distribution dist folder where you'll see the binary. So I've already done that, and I'm going to quickly go to showcase two use cases on Windows. One is using the binary to look at code, and the other one is using a script, the Python script. So let's look at the binary, which I've already built earlier. And here, what I'm going to look at is a C++ code which has intrinsics in it. So I've given the command line argument pointing to the folder which has the intrinsics in it. And for output, I can change that to an HTML file or a CSV file. So let's keep it a CSV for now and see. Now, if I look at the file, it says that the name of the file shows up, the line number, and it says what's the x86 intrinsic that I've used. So if I look at the code, that's the part of the code which it's flagging because I've used x86 specific intrinsic. So this is an example of an issue which the tool would actually report. Now looking at another example where, let's say, you have inline assembly code for performance reasons, and how would the tool do that? So for this time, I'm actually using a Python script instead of the binary, and the other parameter is the folder where you have your source code, and the output would be a file where you want to have the output sent out. In this case, I'm choosing HTML. So if I run this and just pick that file up, so it talks about there being architecture-specific inline assembly. So if we look at that folder, it has x86 specific assembly instructions in there. So the tool has flagged that as something that you will have to port to ARM as well. Now, I want to showcase one more thing besides C, C++, is how to use another language, let's say with Java, the issues that the tool would find. So I'm going to use, again, the binary, and I'm going to do Java code. In this case, it's going to be source code for Spark. As you can imagine, that's a lot of files in there. And let's see. So this has around 20,000 files. I want to showcase how quick the tool can run. So we have around 20,200 files. And I'm going to say output Java, HTML. Okay. So while the tool is actually going through the Java code, I want to showcase this now running on an Amazon EC2 instance. And if you look at it, it's a pretty simple instance which got just one CPU. And I'm going to be using a binary which I compiled for Linux in this case. And it's a C++ project. And let's see that you don't need a very heavy-duty machine to go for the tool to be run on. You can use a very simple machine as long as you have Python 3.10 installed and Java if you have Java source code in there. So while it is doing its thing, this is something I run earlier. Let's look at the output. So this shows the output of the file that I had actually generated earlier. So this were around 4,000 files, and it was done on a single Sprock machine in like 2 minutes or so. So it's still running. I think another minute or so it'll be finished. Meanwhile, let's go check on the Java output. So that was done in close to 17 seconds, and that was the full source code for Spark, which is like 20,000 files. So the tool is pretty simple to use. It's pretty snappy, and I think it'll be useful in helping with your codes. The final thing I want to call out is the boarding advisor for Graviton helps customers quantify the amount of work that is required which is an important consideration. So it's not going to do the port for you, but it'll at least tell you how much of effort is involved. And it'll accelerate your ability to move to Graviton-based EC2 instances. If you run into any issues, you can go to GitHub and submit a bug feature request there. Finally, there are two links. One is for the blog, which I mentioned earlier, which has more details on how to run the tool, and the GitHub site, which has the source code for the tool. So hopefully you find that useful. So I'm now going to pass it back to Michael.
Thanks, Vishal, for that demo of Porting Advisor for Graviton. As you can see, Porting Advisor for Graviton helps identify issues that might come up while evaluating Graviton that you may need to identify and remediate. So taking it from the beginning, you may find that it's actually very easy for you to adopt Graviton. And there are several ways to make this process very simple. One is by using existing managed services and migrating to Graviton using those managed services, such as RDS and Elasticache. Next, take a look at quickly migrating your Lambda functions to Graviton by simply redeploying it using the x86 architecture. Consider also looking at managed compute for containers, such as AWS Fargate for ECS, which also has support for Graviton. You may find that building your containers for Graviton support or multi-architecture support is very easy because most of the major container base images are already available and ready to be run on AWS Graviton. You'll also find that for EC2, most of the major base AMIs that you may want to use are also available for Graviton already, simply by looking for those that are compatible with the ARM64 architecture. Finally, consider checking your code with Porting Advisor for Graviton to identify any issues that might come up during the migration process. On behalf of Vishal, I'd like to thank you for attending this webinar. And if you have any questions, you can write us at our emails, which we've shown here on the slide. Thanks and good luck.